It's me, Tucker. Here to show you my project for 2.2.8 on PLTW, which is the pen accessory. So I had to my original idea for the pen was to have it be, like the accessory was to have it be a grip, but that wasn't really feasible with it being on the top. So, like, with one of the requirements being it connect to the top. Now I realize that looking at the discussion page, that I didn't need to do that. But I've already got this modeled and everything, so yeah. Anyways, let's get to the information, starting with the design brief summary. The goal for the project was a design accessory that would add to the utility of the pen that we had previously created in Lesson 2.2. This came in the form of a pencil accessory that had the following requirements. Criteria. The accessory must attach to the pen with the thread atop the pen. The accessory should have the same or less volume than the pen itself. The end of the pencil must allow for easy swapping of lead. The pencil should be easily removable from the base of the pen. Constraints. The accessory should be fully designed by 10/29/20. Oh, how I was wrong about that. The accessory should be no larger than 20 cubic inches. The pencil should have a similar tip to the one used in the pen. The accessory should contain no more than 5 parts. Here is the attached Google Doc that contains near most of the information that's not on here. So let's go to that real quick. It's loading. Alright. So, here's my original questions actually the original answers to the questions that were given to me at the beginning of the design. I actually answered these. This is why I had this Google Doc before I had the presentation. Here's my design brief that is right here. And it basically says, it's all filled out, and it basically says the same things that I had said in the design brief summary, or at least most of them. Here are the 2 concept sketches and the justification. I chose concept sketch 1 for the design because of the longer end of the power of the... I can barely read my handwriting. I chose concept sketch 1 for the design because the longer end of the pencil makes the whole object fit together much more nicely. And okay, I'm just not gonna continue that one. I'll cut that out later. Here are the images for the assembly drawings of both the pencil subassembly and the pencil attached to the pen. Now, as you can see, why is there 2 charts here? Well, Steam, please don't ruin the recording. Why is there 2 tables here? Well, the original table here was designed by somebody. We had trouble getting the original bill of materials for the assembly in there, so we just had to do a separate table. Kind of weird, but it works. But the subassembly was all done in the assembly itself. Here are some pictures of them by themselves. The volume of the pencil was roughly 0.484 inches. The volume of the pencil is roughly 4.84 cubic inches. The volume of the pen assembly is roughly 2.043 inches cubed. Here's the visual analysis. I'm not going to bother to read through it in order not to strain my voice. Same for you for the structural, but it's all here. Functional, Yeah, I could probably do functional. Well, yeah, I could probably do functional. Functional analysis. The main function of the pencil could simply be described as a black box model of the following. Inputs. Force from the user and the lead. Functions. Use the force from the user and the lead to produce writing following the path of the force applied. Outputs. Writing/path of pressure from the user. Each part helps in this function as described in the structural analysis and can be performed attached or detached from the pen due to the accessory being its own complete assembly. Expected results. The expected results of the product in a fully functioning assembly allow the cap to be pushed out. Expected results. The expected results of this product in a fully functional assembly allow the cap to be pushed down for more lead to be pushed to the tip of the pencil so that if the lead breaks, then it can easily be replaced. So that if the lead breaks, that it can easily be replaced using a separate lead pushing system not shown in the 3D model. When pressure is applied, the lead pushes down on the paper, leaving a trail of where the lead touched the paper and follows the path the lead takes. Okay. So if you wanted to look more at the 3D model, I'm going to show some more views of it. So here is the design for this. So you unscrew this off the top, or you just take it off, and then this fits into here. As you can see, there's that little gap there. So, but instead of just going through the model like some of the other ones shown in the original 3D model, it actually does have a designated hole. If I go to the assemblies, come on. My computer's not the greatest. Even though it is a desktop, it still has an i5. Alright, so here you can see that the holes basically are an indent of the top part of the pen. And if I show the exploded view, you can see how this all comes together. And our barrel consists of 4 parts, which are with 3 fastenings, so I think that's kind of neat. Activate explode 1. So here's what it looks like in an exploded view. Here's the lead, here's the tip, here's the base of the pencil, and here's the cap. Okay, let's move on. Project reflection questions. Reverse engineering is related to engineering design because reverse engineering is finding out how a product looks and functions. I should cut this bit. Here are the project reflection questions. All of these are also in the Google Slides I'm going to be submitting for the project. My goal for the project was, alright, on to the project summary. My goal for this project was to create an accessory that would increase its My goal for this project was to create an accessory for the pen that would increase its usefulness. I feel as though I have accomplished that goal for my project. The pencil is a useful tool as combined with an eraser. You can have a semi-permanent writing utensil compared to the permanent writing utensil of the pen itself. The design meets all the criteria and constraints specified in the original design brief. Here's where I'm going to put this YouTube video. And here's the Onshape link. And that is all. Alright.